we had a week missing, but yeah. But seems to be coming back.
What happened with the recording?
Adobe Flash Player was blocked because it is out of date.
So you have to
Run
update.
this time.
So let me try again.
See that at the top of the line?
Yeah, no.
Adobe Flash Player was blocked
Next
because it is
update.
out of date.
Run this time?
Yeah.
Maybe, yeah.
Yeah. Technician. Alright guys. Good afternoon everyone. Today we're gonna have two empirical exercises regarding our model 8 chi-square, right? So before that, let me just let's have a quick review about what we have done last week. So by the way, your business report will due. I already sent you an email today. Reminder, your business report will be due on 13th of May, this next Monday at 10 a.m. So how's your business report going? Good?
Not bad. Almost done.
A lot of assignments, huh?
Yeah, so many.
Assessments and assignments, different stuff. Oh my gosh. Anyway, the submission, don't forget to view Blackboard. Avoid to copy from others and try to submit it before that time, before 10. Otherwise, you're going to put some
Can you push it out to 1?
penalty.
I can push it out to 1. Gives a bit more time.
Really?
That's going to make any
So, yeah, that would be fine. You are so. I'll be in, guys. By the way, tomorrow I will be in from 1:30 to 3:30, maybe to 4. I can add half an hour for you guys. If some of you guys have an issue with your business report, something is not clear, you need some more hints, explanations, just come and see me, please, for the business report, right? Got it, guys? So come during consultation hours. So I was waiting for you guys. Just 2 students today came. I don't know. This is a good indication that I think you've done well. If just 2 students came during 2 hours consultations. So I hope you've done well. But still, if some of you guys need have some issue with any of these 4 questions, so feel free to come and see me tomorrow afternoon. All right? So quick review about what we have done last week. So if you remember, our model 8 was chi-square test. There's 2 stuff to address, 2 things. If we have one single population, or compare one single population, we're going to use multinomial, which is some extending of binomial test, right? But for binomial, if you remember, we have 2 output. Here we're going to have more than 1 output, and the formula is clear in here. You have to use expected and observed values or frequencies, and we have a chi-square rejection region. If you remember, I said to you guys, it's same for F, but it's not same in terms of the, but F and chi-square here, x square, it's both greater than. There is no small than some value. Both greater than some value. If you remember, if F and chi-square. If we compare 2 or more than 2 population, we're going to use contingency table, which is a very important, guys, in your business report. If you specify or identify or read the questions, you can address and you can detect which one is that related to chi-square. Question 1, question 2, 3, or 4. It depends on your knowledge and your reading. Anyway, so with the contingency table in here, we have to have some different formula than comparing with the single population. We have to do some extra calculation to find the value of x and then compare it, or also see the how it's going with the chi-square critical region, and whether we're going and see the decision whether we are going to reject or accept no hypothesis. That's the material of our last week model, Model 8 chi-square. Single population, two population. This is the material, right? Empirically, we have to follow this structure. If in your business report, even in final exam, it will be allocated one question. So you have to follow this. Define the parameters of interest and see whether you are addressing single population or two or more populations. Then you use the right formula, rejection region, find X, rejection region, and conclusion. Conclude whether like this, like we're going to reduce, reject null hypothesis because we don't have sufficient evidence to infer that, blah, blah, blah. It depends on the question and the nature of the question. All right? So, sorry. So today we have, as we said to you guys, we have two empirical questions. So one, for sure, one related to the single population, and the other one related to the compare two or more populations. Okay. Don't forget to use the right table to find the critical value, like F6, and for chi-squared was 5, right? Table 5. Yes or no?
Sorry?
Table 5 for chi-squared?
I can't remember.
Yeah, table 5. So we have exercise 16.14. Right? Yeah, 16.14. So try to highlight the parameters of interest in here, like the schedule is important, 100% to determine whether you collect the outstanding account receivable soon or it may take months or weeks or stuff. So that means the parameters of interest. Read the question so carefully, just have 3 minutes. Highlight the parameters of interest, like 250 accounts receivable. So that means our parameters of interest will be account receivables, because customers not paying cash under account receivables, right? Why it creates customers not paying cash? They got terms of credit, and they are allowed to pay, right? They are allowed to pay within a certain number of days or months, right? That's how to create accounts receivables in the account records, right? So management, accountants, they plan to do some schedule to collect the accounts receivables based on number of days, right? So check. Based on accounting estimation, accountants believe that the aging schedule of collecting accounts receivable will be affected maybe by the economic downturn, right? That's what they believe because they expect there is some recession, right? Coming soon. You highlight these words. Right? There is some, yeah, here. The company would like to know if the recession has affected by aging. That is the key. So, what do you think in here? There's one important parameters of interest in here that we're gonna to do the schedule. Divided our schedule to collect the aging outstanding account receivables into 4 categories, right? P1, P2, P3, P4. That's equal to 200, I think. Right? Right? So we have one parameters of interest, right? Which one is that?
The
Yeah.
change in the
Accounting receivables.
Yeah.
Accounts receivables.
Yeah.
That is, we have one account, one important account that the accountants need to do a schedule to collect the outstanding accounts receivables, right? So based on the length of the period, so from right? 2 categories, 0 to 29 days, right, in here. So first, aging schedule here. First, schedule, right? And here, second, third, and fourth. So 1 accounts receivables into 4 categories. So that's why we have accumulated our frequency, right? So if you go to Excel file on Blackboard, I think it's available, not on Blackboard, it's available on in your book, it's provided. So you can find the raw data, you can find it, and we can say that the data is, well, may have 4 outcomes in here, right? Data sorted into categories. That means it's qualitative or quantitative. What we have done last week, guys, I know you're busy, but you have to remember that chi-square addressed the issues with the qualitative data, right? If you remember, the weeks before, the couple of models was addressing the issues with quantitative data, right? You remember it, guys?
Mm-hmm.
So qualitative. That means we have multinomial. Are you guys with me?
Yeah.
So the population invested in here is accounts receivables. There is accounts we will plan the aging outstanding into 4 categories in here, 4 outcomes. So we're going to have the proportion of accounts receivable impact. This is give us some indication to calculate the aging schedule for each category, right? So it's accounts receivable. If it's 1, based on our model that we're going to use, multinomial, right? Multinomial, single population. If it's multinomial single, there is specific formula and critical region to follow, right? You all right, guys?
Where do we find the observed values one?
Observe values from
The
Excel.
Oh, okay. So it's not here.
No, it's not here, so it's too much. You can't open
How can we
Excel.
do the question without them?
Huh?
Do you have them? Do you have the observed frequencies on you?
So I will show it to you.
Oh, okay, yeah.
I will show.
Yeah.
That's why, yeah. That's why I said to you guys, please try to. But I know you're busy,
Yeah.
so if you go to the Excel, you can find it. So I'll show it to you. Just let me step by step.
Yeah.
And here, null hypothesis. This is the fact we have that P1 equal to, because it will equal to the has to be equal to 1 because it represents all sample space from last week model. So critical region in alternative hypothesis in here, they said if one what is the critical alternative hypothesis, at least one of these 4 categories, right, is not equal to the specific value, because we expect that the economic downturn will affect the aging schedule at least for one of those categories or these outstanding accounting receivables. That's what we believe as accountants, right? If you read the question here, the company would like to know if the recession has affected the aging schedule, right? That's the question. Highlighted this one, guys, because that we will build or develop our because we're going to develop our hypothesis based on this information. What the accountants believe? They believe that the account or aging schedule will be affected by the economic downturn, right? So let's test our belief. Let's test the accountants' belief, because they believe there will be some changes. Let's test it. Identify the parameters of what's the parameters of interest? Accounts receivables. That's what we are interesting to have. Divided the accounts receivable into 4 categories based on the age of the accounts receivable or the outstanding accounts receivables, right? And then use the right formula. Once you use the right formula, you have to find the frequency. So that's the formula. Here, 250 is the number of observations. Here, for the because what happened? You have to calculate the observed frequency and expected frequency. The observed frequency, guys, it's from the question. You can find it from the raw data, right? That's the observed. You can find for observed for category 1 equal to 159. The observed for category 2 equal to 28. The observed, that's from question, that Excel. The observed for category 3 equal to 47, and for 4 equal to 16. So the expected value equal to, right, the number of observation in total equal to 25 at 250, right, times the proportion of each category. Right, guys? This one from the question. That's a category from the question. P1, P2, right? So, we're going to have, it's down to the slides. So we're going to have the expected for each category and observed, because 2 important things to calculate. Expected and observed, right? Once we have the expected or observed, so let's test our belief that if one population in each category has been changed, that means aging schedule has to be changed also, right? That's what we want to test because of the economic downturn. That will be affected. That's what we expect, right? Right? So that's even in the business report, by the way. I want you to show me the calculation of. It's different 2 population. But I want you guys to show me the calculation, how to calculate chi-square, right? Not just do final numbers, and I want you to show me the formula and how to calculate chi-square. Summation of observed minus expected squared divided by AI for 4 categories in here, right? Alright guys, so we're going to have chi-square equal to 33.85 because of the calculation. If you want to do it using the Excel, you have to do some code manually because there's no specific function to use in Excel. There's some in advanced softwares like SAS or Stata or R, but it's not your material, the material of your unit. It's different. So you can do it manually, right? So that's the rejection region. Guys, I want you in business report to follow this strategy, like this. Okay? Define parameters of interest. Check if there is some additional stuff, like rule of 5 or stuff. And hypothesis, chi-square. But I want you to show me the calculation. And rejection region. After rejection region, there's another 2 steps. You have to decide, you say decision, okay, reject. And conclusion, yeah, we reject because of that, right? That's the structure of. So we have decision. After the, you have decision and you have conclusion. After the, that's what I want you to do in the business report. After you find the critical, decision, reject, okay, or accept, okay. Conclusion, conclude. Okay, we didn't find enough evidence to support that. For example, if you're gonna reject, we didn't find enough evidence to support the accountants believe that the aging schedule of outstanding will be affected by the economic downturn or due to the recession.
But we did, didn't we?
I don't know. Let's see how we go.
Oh, okay. Sorry.
So for sure, it's chi-square is too big, so you have to reject null hypothesis, right? Compare with the 7.8, right? You still less than chi-square stuff. That's reject equal to 7.81, right? And rejection region, right? It will be in this area. Right? So reject null hypothesis at 5%, which is the default value, but in business report, guys, don't forget 3. So in here, reject significant level, the recession or current downturn as affected by the aging, right? So that means null hypothesis is not correct. We support the alternative hypothesis. All right? That means the aging schedule will be affected, 100% will be affected, right guys, by the economic downturn. If someone borrow a couple of million from the, so even the publicly listed firms or other like individual or companies, if they borrow some big money or stuff, so the aging schedule will be affected for banks or for individuals. Right? Or capital providers, I mean. Right, guys? Got it? You know how to get from table 5? So this is for 5? Okay, go to the question itself. So what we have? We have k minus 1 means 3. 4 categories minus 1 will be 3. Right? 5% will be. Yeah. Got it? Because last week was it? Right? So guys, you know how to get this stuff from the table? 5? Chi-square critical. You know how to get it? Guys, your business report due on Monday. So you know you have to get it. You want me to show it to you? So it's a part of your business report material on final exam. So last week it wasn't. So we have 7 points. Right? Table 5, 3, 7.5%. Alright? 7.9. The part for critical. Chi-square critical. You go. This one here. Because you have 3. K minus 1. K number of categories. That's the outputs. Like, yeah, because we've divided our sample into 4 aging as schedule as standing. So 3, 5%, that's the default. Alright guys, so got a question about this? Or to jump to the next exercise? I have 5 minutes reading time. So basically when you see like such a questions even in a final exam, guys, you can conclude that you have 2 separate categories, which is a man and woman, and they divide this to 2 different parameters into 2 different categories, whether man want iWatch and man don't want iWatch, and women want iWatch and women don't want iWatch. So please put the total number of the row and columns in here, if you like, because later we're going to use it to calculate the observed and the chi-square value, right, guys? So they adopt a new advertising strategy. So if they want to adopt any new strategy in marketing, guys, normally they use surveys. So these outputs from the surveys, they ask the men and women whether you are interested to win the iWatch or not. Yes or no, it's category. This numbers here provided is the frequency of these categories of the surveys. So after we collect the surveys from the participant, we found that. You agree, guys? Mm-hmm. Ahmed. Question 2. You know how to address such a question, guys? It's easy. Once you get such a stuff in here, that means you have a contingency table or question with 2 or more than 2 populations. So the desire, so we got the answers from the men and women that got answer yes, I want, or no, I don't want the iWatch, right? No matter if you want or no matter. Yes, I want. No, I don't know. I don't want this iWatch, right? So again, this numbers is a frequency of each category. It comes from the surveys. So the desire to own the iWatch and customers' gender are qualitative data, right? It's a qualitative data. Use chi-square. Which one is that one? Multinomial or contingency? Contingency, right? Contingency. You alright, guys? You agree? Contingency?
Oh, sorry. Which question?
So, parameters of interest, desire on this iWatch, and the customer gender are qualitative data, right? That means it's chi-square. But we have two independent or two separate populations. That means we're going to use a chi-square, woman and man, gender diversity, and you have to use chi-square test for contingency table. That means you have to divide it, find the total like what I have done in here, and you have to find OI, observed, and expected, and apply the formula, right? There's a problem with the recording. And apply the formula, right, guys? See? After applying the formula, we're going to have, that's the total as I told you guys. So, see, let me just explain the hypothesis for you in here. So the question in here, whether you want, so they expect that it's, here there's two options because of contingency. There's men and women, and someone who want to watch the iWatch. Some of them, it's for men and women, both. So the section of the hypothesis in here, we have for the null hypothesis, there is the two variables, desire to own the iWatch and the customer's gender are independent. That's the fact. But what they believe, or what they want to test, that there is some, these two variables, like desire to own the watch and gender, customer's gender are dependent. So that's what we're going to test, right? Once we're going to test, we have to do the contingency table, guys, first, and apply formula and the critical region, right? So as I told you, just in the final exam, by the way, and even in the business report, you have to do that one. Why? Because it will be allocate some marks in the final exam. I want you to show me the total, right? Because from the total, you're gonna it will help you to calculate the chi-square model. So it has to be done in the final exam. I will provide you with this one without the totals. So just add up the columns and rows, right? So that's a formula. For the contingency, it's slightly different, right? Compared with the multinomial. Multinomial is a bit easy. This is just by wanting you to show me the work. Even the business report. For the first page of the chi-square question, show me the parameters of interest, rule of 5, stuff, blah, blah, the chi-square value. If you want to put the calculation, that's fine. But if you add this sort of things as the second page of the report, like here, question 1, for example, like this is your exam or business report paper, right? So the first question, for example, if it's chi-square, parameters of interest, condition, if you have rule of 5, central limit theorem for a couple of questions, or equal and unequal variance, so I want you to show me, right? So and then hypothesis. After hypothesis, chi-square and OI and EI, check the calculations. You can put the calculation in the second page in here. Contingency table, put it if you like. You can put it in the first page, but it will be less organized. Define parameters of interest, condition, hypothesis, chi-square, OI, EI, expected, right? These calculations, you can put it in the second page in here, right? And finish. Next step, critical region. Compare, and then compare chi-square value with the critical region. Chi-square greater than chi-square, so greater than some value. And then decide, say decision. Reject or accept the hypothesis, and the last step, put the conclusion. Yeah, we didn't find enough evidence to support that the two variables like desire tone, the eye watch, and gender, customer's gender are dependent. For example, right? This is for chi-square. Put the tables and formula and they as attached. This is the next question. Like for example, it's ANOVA. Like put the ANOVA stuff in here, different parameters of interest, same. Parameters of condition, hypothesis, F test or depends or T, and same. The Excel output, put it in here, in the second page. Then, question number 3, put the stuff in here. If you have any additional stuff, put it in as a like Excel output.
Oh, so we do put the Excel output in?
Yeah, you have to put it.
Oh, I thought we had to do it all manually.
For ANOVA, you have to put it.
Okay.
For ANOVA, because even for ANOVA question, you have 3 different histograms based on industry type. Customer discretionary,
The materials and telecommunications.
right? Optus, over the phone, right? So, and show me. Put it small, don't make it big, but put it as attachment. Don't put it in the middle of the question, be less organized. Alright? Question number 4, it will be same for the question number. Let me just, we forgot our question. We didn't get to it.
Don't worry.
So, I'll give you 10 minutes explanation at the end of this class, right? Today, after finishing model, the regression model. Because there is a couple of hints, maybe most of you guys forgot to put it in question 3 and 4. Anyway, contingency table and formula, right? By the way, it will allocate 16% of your total final exam. Question from chi-square. Don't forget that one. It's not just in business report. Final exam, right? If it's done in a business report, that means everything will be easy. So you have to calculate the observed and is observed already available, but you have to calculate the frequency or expected. Sorry, expected. How to calculate the expected? We have the total for men 150. Remember it? And total 150 divided by the 52. I think from Excel that's the right. Divided by total number n. That is the formula, right? Equal to 26. That's how to calculate the frequency, the expected value. Then we use the formula chi-square equal to 1 category 2, 3, 4, right? 4 calculations, and then because if you remember, this is 2 based on customer desire and the customer's gender, and we have another 2 like desire of the customer, whether they are they want to want the iWatch or not. That means yes, no in our business report, and 3 different industries, right? So you do this stuff. So in here we have the that's the way we're going to test. We're going to test that the 2 dependence variable from desire of the customers to own iWatch or not, and the gender diversity. So that means we're going to have the chi-square in here, model, and then the rejection region. So in rejection region, we found that chi-square less than chi-square critical, right? If chi-square, that means chi-square located in, falls in, which non-rejection region. Are you with me, guys? If it falls in this region, that means we are not going to reject null hypothesis at 5% significant error. Clear? This is your material, very important in the final exam. One question will be allocated to cover this model. So maybe it will be will equal to 16%, maybe around 16 of your total final exam. Great, right? So, do you have any question about it, guys? Otherwise, we're gonna jump to our new model, model AA9, regression. All right, guys, done? Not yet? So remember, in final exam, you have to add up the columns and rows, and you show me all the steps, even in a business report. Like business report, it's not clear like this. You have to do it manually a little bit. What do you think, Marco? You have to do it manually or ready or?
My report.
Yeah.
I've got to do the written component.
Yeah. If you use the Excel, because if you manually, you have a couple of decimals, right?
Yeah, yeah.
If you use Excel, just copy and paste the
That's actually something I wanted to ask you. How
No,
many?
this is not. Don't worry about the decimals.
Okay. Yeah. 2 decimal places, okay?
Yeah.
Yeah.
Even when you add it to the stuff,
Yeah.
so it will not change it, because if you just take 2, the difference will be, instead of 30, it will be 29. The decimals, not the
Yeah, yeah, yeah.
not the value.
Yeah.
To the decimal.
So it doesn't matter to the
No, no,
decision.
no.
Yeah.
But the critical values, now I want it from the
The book. Yeah.
All right, guys. So let's jump to the next model. If you don't have a question about stuff. So today, guys, we have a new model, call it the regression, which is the very easy and very important in your, work, like if you work as accountants, professionals, and or like as a management accountants or financial accountants, you're going to use a lot of simple, regressions. So today, we're going to have a new model that is totally different with what we have done previously. Actually, when we say regression, that means there is two interesting variables to test. One, we call it independent variable, which is x, and another one, it's dependent variable, which is y. Right? So we want to check the y based on x variable. But today, we're going to have just one x, because when we say simple linear regression and correlation, that means we're going to test the simple linear, which is, it's important in the statistical analysis, but it will not give you the value of y or change in y in details, because you are not going to control all the facts or factors that will affect y. I will give you some examples to show you how to find the importance of. So today, let me just give you a quick review about the material from my experience. What students been done in the couple of semesters before? In final exam, guys, the regressions, because for the regression model or models, we have the simple and multiple, the model 10 next week. Please listen to me carefully. Two models. Both of these two models will combine together and we generate one question. So this question will be a bit long. It will be the last question in your final exam. But that one is not a material of business report. I'm talking about final exam now. Right? So it will be allocated as a comprehensive questions. This comprehensive question will equal to 25 to 30% of the total grade in final exam. So most of the students, most of them, I'm not talking about, most of them, what they did in a couple of semesters before, they just ignore it. It's the last question, and they just ignore it because too big, they don't have enough time. But they forget that it will allocate 30% of their final exam. So don't forget to answer this question. The last one will be combining between, it will be like a combination between model 9, simple linear regression, and multiple linear regression next week model 10. So question, I think I put 28 marks for the question 6 in the final exam this semester. I will show you also during the revision or mock exam material, a comprehensive question mixed between model 9 and model 10. So in model 9 today, we have simple linear regression. When we call simple, that means we're going to have 1x. When we say 1x, guys, that means one independent variable. So x is independent variable. Independent variable, and x is dependent variable. All right? X and y. Simple linear, that means there is no more x. I just want you to understand the name of simple. Why simple? You see, simple linear regression. Okay. Because you're interesting to prediction. We said prediction. For example, you want to predict your mid-semester grade. What is the variable that will help you to predict your mid-semester or final exam mark or grade. So number of studying hour per week. That's X, right? That your final exam score, for example. So how to predict that? You have to control for the number of hours, X independent variables. Study more per week, you got high score in final exam. Right? That size of the firm, X will get high performance, right? ROA. So study more, got high score. But there's additional stuff to help you to predict significantly and accurately to predict your final exam score, like your age, number of children you have. If you have a lot of children at home, if you study from morning to evening and they do a lot of headache for you, so you read from here and it goes from the other side of them, right? So that's we call control variables. When you predict the price of this car, used car, what you have, that price will be Y. X is odometer, color, this is X variables. Control of this to find this, the specific or to determine the price of the car. Right? That is it. Here there is just one X. That's why we call it simple linear regression. But next week we're going to have more than one X. We're going to have steady hours per week. We have the age of the students. We have the another control variables. We call it multiple linear regression. But here we're going to have one X, one Y. Right? That's why we say simple linear regression. Simple linear regression. So that's why we put correlation with it. Why? Because the correlation matrix will measure the association between two variables. No matter, there is no more effect. Other effects will be excluded, right? So correlation will test the association between X and Y. Right? So now if you read any published paper, you will find, if it's not simple, if it's multiple linear regression, you will find the first table they put descriptive and then they put correlation. Because correlation will give you simple regression because it will test two, right? X and Y. But additional analysis will give you the result of multiple linear regression. When we say linear relationship, that means there is association, whether it's positive or negative. Let me we'll illustrate some models or examples to make this stuff a bit clear for you guys. So a simple linear regression model, we have the estimating the coefficient because we have beta 0 intercept and beta 1, which is the coefficient of variable x. I will explain to you. We have error, the percentage of errors by using these models because you have to compare with other models. If there is a less error, if you use other models and you got less error, that means the model will be more fit with your data. Assessing the model, there is some couple of like R squared to assess the model, some couple of measurement to assess. After you estimate the coefficient and find the error terms and assessing the model, then using the regression. Run the regression and find the result and check the coefficient of correlation for B1, beta 1, and then the last one we're going to discuss is the diagnosis, or regression diagnosis. What is the errors? How to what is the, sometimes it's not the errors by using specific models, sometimes the errors made by those who collect the data, for example. They add some different zeros, additional zeros, it will change the direction of the association between X and Y, right? But before we start going deeply, this one, all this stuff will be just one click using Excel to find the table and the results. So in the final exam, I will give you the results, and I'll ask you some questions. I will show you how to do it. But don't be, because you're going to see a lot of Greek characters and stuff. So don't worry about it, because it will be clear in the final exam as provided as X. Even I'll give you one example using Excel, and I will show you how to address it.
Today on the Stay-at-Home Chef, I'm showing you how to make
Yes.
authentic carne asada.
So that's good. I think you need a break. That's right. Let me just go a little bit, and we'll take a break for 10 minutes. In this chapter, as I said to you, we're going to have quantitative analysis, the exam relationship between X and Y, right? So we're going to use this quantitative data. Even if there is some, see this is for you, even if we have some qualitative, but it will be allocated within the regression as a frequency, as a real number, 28, 72, 35, but it's in fact, originally it's qualitative, but we'll put it as a real number to be consistent with what we have from the quantitative variables. Like when we do regression, it's a bit early, later. I'll show it to you. When we have regression, normally in accounting, we test, for example, firm size, X, Y equal to X. This one, normally we put firm size, for example. Right? Y, ROA, return on assets. This is a profitability measurement or performance measurements, same. This one, in accounting, you are accountant guys, you need to know some terminologies on how to, why we use, because later you're going to read one paper, they don't use ROA, they use market capitalization. What is the difference, as an accountant, I'm asking you a question. What is the difference between ROA and market capitalization? Both is a performance measurement, but what's the difference? As an accountant, see, that is the importance of the link between the statistics and accounting. We use ROA. ROA is a performance measurement, and market capitalization is also a performance measurement. ROA is firm-based measurement based on the data we have in our firm, but market capitalization is market-based measurement. See the differences, guys? So some of you, they said, yeah, we have to. So that's why if you if you do any analysis, you have to have some consistent in the result when we're going to use ROA or market cap. If your manager asks you to find the performance for this year, and he asks you to use both measurements, ROA and market capitalization, because it has to be consistent. If the market capitalization less than ROA, that means there is some agency or information asymmetry, conflicts or problems. This is a pure accounting, right? Let's go back to this. But see the differences and the connection. How to test? Firm size. Big firms have higher performance, 100%, compared with the other counterparts, right? But in here, why we said it's a quantitative, but sometimes we put qualitative data, right? But it's a frequency, like in some data like corporate governance, number of independent directors, right? Independent as a control. If you read any published paper in accounting and corporate governance in accounting, they use independent directors, they use Big Four and non-Big Four, and they use a lot of qualitative data. But combined with the quantitative regression, because they just give the frequency, number of independent directors. That means it has to be like qualitative, but it's give us the numbers. So we can put it 7, 3, 5, right? Such as this sort of variables can input in the regression, right? So just want you guys to understand the logic of the regression. We have x and y, x the independent, and y is the dependent variable. Right? So dependent variable, what is your interest to predict? My interest to find the ROA of the Commonwealth Bank for this year, 2018. So what I want to control, I have to see the size, for example. I have to see, maybe not the size, maybe the structure of the management, maybe the leverage, the risk, different X you can use. But in our model today, model 10, and model 9, we just have one X. So what's the dependent variable Y in here? We have ROA. I want to predict the value of ROA for this specific term this year. What is the, see, independent variables here, they put x1 and x2, which is the, how many variables or factors used to predict the variable of I. So how many factors in here? In our model today, linear, you just have one. But next week, just link it, guys. Next week, we're going to have firm size, leverage, right? Age of the firm, very important variable. Number of independent directors on board, right? Structure of audit committee, because structure of audit committee, if they have more independent variable and more professionals with audit experience directors, they will have good monitoring expertise, and they will reduce the agency and earnings management and frauds and playing in the accounts, records, and the business and the final annual reports. See the link? That's why we use it. So from the beginning, at the first of the semester, 26th of February till now, this is the most important one. Right, I agree with you. Hypothesis testing, probability, but at the end, when you press the bottom of regression in the Excel or in any other software, you have to, once you say regression, it will give you the summary, it will give you the descriptive statistics, the summary, ANOVA, and the association between X and Y. So it's like time series, a long chain from beginning to now. We have 9 models, and we'll be to the next week model 10, a multiple regression analysis, and will give us stuff like the whole idea about the regression and the effects and how to predict X and Y. So for our today model, so we're going to have X and Y. So just go quick of this because it will be part of the. So something interesting to find, which is beta 1 and beta 0 and beta 1. Beta 0 the intercept, okay? And we have x1, x2, x3, depends, till x, all right? And we have beta in here, which is the coefficient of correlation of the x variable, which is the independent, right? So error terms, error variables, that will be given already, guys, in the regression. Will be given, right? So if we want to find, for example, that's the slope. The slope in here is beta 1, right? How to find beta 1? So we got y hat 1, y hat 2, for example, y hat 3, right? 2. So we got beta 1 equal to y hat 2 minus y hat 1 divided by x2 minus x1. So we have raise divided by run, right? So how to find beta 1? This is the simple linear regression, but this is, we call it actual regression, because next slide I will show you the predicted one or estimated. With the predicted we have error terms. The amount of association or the value of the predicted, the association between x, y, which cannot be captured by this regression. That's why if we add more x, we will reduce error terms. right? So in here, still we've got 5 minutes and we're gonna got 10 minutes rest. Because this is important, I want to go before the example. So in here, they give us an example on how to, they give us some association between x and y, and they ask us to see the strength. So they give us some negative association between x and y, not positive, negative, right? X is independent variable and dependent variable, y. And they ask which strength line first best. So they interpreted this one and provide us with some numbers in the next slide in here. So, for that, let me just explain this one for you, right? So, and here, guys, they ask to estimate which could be better. We have two important, based on the lines, negative lines provided. Let me just show you. Oh, sorry. So, if we ask to find the strength of the lines between two different associations, we're going to use least square method. This, based on this method, you can use the actual value of y and predicted value of y. Let's see the first summation of square differences. So that's the method, right? So in the first one, summation of y bar y minus y hat squared. This is the how to calculate. So actual y and predicted y, right? See the predicted? This is the actual 2, 1.5. That's it. And the predicted in here. So that we have the first line in here, second, third, and fourth line, right? So the actual is 2. The predicted, which is y hat 1, y hat 1, y hat 2, y hat 3, y hat 4. So that's the predicted, actual. Based on the formula, you have to find the actual minus predicted, right? That's the actual, that's the predicted. Based on the formula, we're going to have the summation of square differences based on this method. The summation will equal to 6.89. But if you use different strategy to find the summation of square differences, we're going to have the actual value or the some smaller, we call it the second line, which is the horizontal 2.5 y hat in here. It will be fixed based on this value given. No matter what x we have, but we have the predicted one fixed with the compared with the actual. So predicted in here we have different, right? 1, 2, 3, 4 predicted y hat. But in here they provide us with one predicted y hat with different actual value of y, right? 1.5, right? 2, 4, 1.5, and 3. 2, 4, 1.5, and 3.2, right? That is the y. This one, guys, and here, if we compare, according to the least square method, they said the smaller the summation of square differences, this one, summation of square differences, the smaller one will be better fit to the data that you have in your software or that you're going to test. Right? This one is the logic of the regression, it's too complex for you. You are not statistician. It's not your. This one will be. It's not important in the exam, but the most important one, the outcome of the Excel. So I will give you. This one will be more clear when we illustrate one example. I'll bring one already. Allocate one example for you guys. I will show you how to use the software. This is your. No need to. You need to understand it, but it's not that much important. But you need the most important part to understand the X and Y and to use the Excel regression function and to interpret the predicted and actual value of. So because in here, sorry. See, in here we have predicted. Let me show you the differences between predicted and so see, in here we have predicted. To estimate the estimate sample linear regression equation, that estimation of the equation of the first order line. So this one, the estimation, estimated or predicted, right? Model. What's the difference between predicted and the actual? The actual, it's y equal to beta 0 plus beta 1 x plus error term. That means with the predicted, there is no error terms. With the actual, there is an error terms, which is the most important in our study and in our work and to find the linearity between x and y, or the relationship between x and y. Right? That's the actual one. Here is the work. Ah, sorry. You didn't finish it, right? Finish? Right? Got it? 10 minutes rest, right? Or you need the example. I want you to take rest because the example is important. Take rest for 7 minutes. 7, not 10. All right, guys? Oh, it's not working. Oh my gosh. Not charging. Oh, that one. Charging because someone used it before me? Because I've heard some like sounds from the mic during the class, but I just look at there some different colors flipping, but I don't know. Flashing, I mean? But I don't know. What's the reason? So we was a bit busy with the regression and stuff. Alright? No worries. Lisa last time, she said Mark already sent you an email on the
Yeah. I sent her an email, and she sent me the response about how to apply the discount. I think it's a discount that I was asking about.
no, not just this now. There was a schedule. accounts payable and
Yeah, yeah,
stuff, suppliers, and I said, what was it? Suppliers, right?
yeah. So it was. I think it was a discount received on a
Yeah, I said you had to
early
divide
payment.
it that stuff.
Yeah, but so we ended up just adding a line item in the bill. Yeah,
Probably, I don't know.
yeah, yeah. So you can't. I don't think you can do it from
The environment that feed into the software. You
yeah.
have
So
to
you
add-
can't do it with a credit note because then it doesn't go to your discount received account. So yeah, we figured it out in the end, but we're still struggling with this assignment. Huh? Ah, fair. Yeah, yeah. Mm. It's tough because just because like don't have much experience with Zero.
Ah,
you know.
that first is
Hmm?
one person. I mean, our business group.
After data,
Yes.
yeah, not too bad.
I just need to remember what we have done.
Yeah. So much to do in the next 2 weeks. Yeah.
Next week I have to mark the business report and the assignment. The 17th.
Yeah, it's due on Friday next week.
Yeah, so I have to mark the data, the business report,
Mm.
and the new assignment for
Mm.
half a month more.
Mm.
In addition, I have a lot of projects. No time for research.
It's hard to balance everything. I feel like everyone's feeling busy at the moment.
Yeah, you need to work on your projects to do some research because we have to do some research.
Yeah.
Otherwise, we'll stay the same
Level.
location, just
Yeah.
turning around and stuff. So,
Balancing teaching and
Yeah.
research is.
Yeah, I did two classes. I did student training at a time.
Mm.
Tomorrow,
And then 2 postgrad.
2 years supposed to be. So tomorrow in classroom, right?
Yeah.
Two plus,
I'm behind on cash flow. I need to catch up.
better.
Mm. Yeah.
Yeah.
Yeah. So my understanding is that you've got your balance sheet and your P&L, and you use the items in the balance sheet and your P&L to find
Yes.
the balancing figure in your
But
T
what
accounts,
happened-
which is cash
what
in and cash out.
Wow, that's what I did last year.
Yeah.
Because I used to be the lecturer of, not lecturer, I was doing some tutorial. It's also have one, the topic of cash flow statement. What we have done, we give them the material, couple of examples, like tutorial questions, and the exam, we provide them with the formula empty.
Yeah.
I
Okay.
will help them to do well. I asked Miss Lisa,
Yeah.
then she said no, we'll be not good. Because you're a master's student, you're supposed to.
Well, not all of us are masters.
Yeah, for sure.
I'm grad dip.
Ah,
Yeah, grad dip.
I mean, it's postgrad. At
Yeah,
least.
postgrad. Yeah.
Postgrad, let's say.
Yeah.
So at least you have to have some background.
In what?
Some background about the structure of the cash flow statement.
Not me.
Yeah, most of you guys.
I don't.
Yeah, I know. Most of you guys don't know.
Yeah. But the university assumes that we do.
If you said postdoc in accounting,
Mm.
we suppose that you have some good background in accounting. If you ask in general,
Yeah.
but in fact, no.
Yeah.
Most of you guys have. Like our
Minimal.
example last week, it was BA in engineering.
Yeah. That was a contingency table, wasn't it? The bachelor's and the
Yeah.
and the master's program. Yeah.
It was funny. It was stay just the all this stuff.
Yeah.
How are you?
That's bad.
Lot of assignments and tasks, assessments to do, huh?
They're taking 5 years. Crazy. At least I have at least an exam and an assignment each year. Each epic. At least. For this 2 exams, 1 assignment. This week I have 2 assignments, 1 exam. Yeah. Too much. I'm almost living here. I'm here till 2 a.m. and I drive 40 minutes to home and I come back around 7, 8 a.m. Something like this. Every single day.
What's my recommendation for you, like, from my experience? When you try to address any question or an issue with the assignment or assessment, read the question carefully. If you understand, because half of the solution based on your understanding for this case study, half of the answer depends on your understanding. Otherwise, you're still struggling. Just like this, no, that, yes, like this. So try to understand the question. If you understand it, nail down the keys, follow the process up, down. That's the strategy. Don't jump here and there. Just try to be stick. Guys? Let me show you the data. This example was like, it's 17.03. Okay. So, I was waiting for you, man.
Sorry.
No, that's fine.
Thanks, guys.
So, we have an example here to test the association or the relationship or the linear relationship and to find or to predict the value of y or to find the association or the linearity between whether there is a linear relationship between x and y. So accountants in here wants to find the relationship between the odometer reading in 1,000 kilometers and the selling price, also in $1,000, right? Of the used cars. See, guys, normally when we do any analysis on when you are going to do, when you got job or in your job, if someone asks you to provide you with the raw data, provided with the 1,000 numbers, so you have to reduce the figures of these numbers into, for example, 1 decimals, right? So it has to be consistent. To what extent that you have 5, 10, 15 variables, you have to have the data. I'll show you one raw data from the Australian public listed firms. The size is measured by total amount of assets, what's in million. But we reduce that millions into small figures of these numbers to find the real association, or to find because later if there's some variables will be in the figure numbers. If we have some variables with the real figures numbers, big numbers, that means the association will be, or the prediction will be incorrect. Maybe the direction of the linearity will be opposite. If it's in real negative, it will be positive, right, between x and y. If it's positive, it will be negative. So the figures of the numbers will change the direction of the association or relationship between x and y. So in the exam, or when we test any association between x and y, we're going to have some data, raw data, consistent. The figures has to be consistent. That means if the odometer in small figures, the price has to be small figures. If the total assets of the firms reported in the small figures within our data set, the size, the total liability, total debt, total tangible assets, the other variables like revenue, like ROA, ROE, all has to be in small figures and consistent. There's consistency, and when we shape our data sets, or to report, or to record the data that we have. Otherwise, when you do some tests, the association or linearity will be different, or take opposite sides. In addition, when you conclude, this is important in the final exam. Now we provide you with the small figures, but when you do conclusion, I want you guys to report in the real numbers. Like, increase in 1,000 kilometers will increase the price or decrease the price by $2 or $3. Right? I will show you how to report that. Here, guys, this is the real fact. We have an example. An accountant want to see if there is a relationship or association between the odometer of the car and the price. Why we use odometer as X? Because the odometer, to what extent the car has been traveled, we're going to use this proxy to predict the age of the car. Note it down, guys. Use odometer as a proxy to predict the age of the car, right? So when we control for this one, when we have the X, right? When we have the proxy of the age of the car, we can predict the Y, which is the price. 100% high kilometer, low price, right? But there's some additional stuff. It has to be an association in here, guys. It has to be an association. But next week, we will add additional proxies. Sorry, do you have a question? I heard you talk. All right. So next week, because we're going to have multiple regression, we're going to add additional proxies. So add additional proxies will reduce the error terms. We're going to add color of the firm. Oh, sorry, not firm, car, right? Color of the car, the model of the car. These proxies will give us the exact number or the right value or price of the firm, of the car, sorry, the firm, because I talked a lot about the firm, right? So the specific amount or the market value of this car, specific car, because we're going to control on more additional stuff. So we use the odometer as X, and the dependent variable is Y, which is the price. That's what we want to predict. We want to predict the price of the car using odometer as an independent variable. So let's see the output of the Excel, and I will show you how to do it, because I already have this, the raw data of this example. So we're going to have, this is the output of the Excel. How are we going to get this one? Couple of, let me show you the Excel, how to do it. Before I explain this to you, let's go to Excel. How to predict. So now we're going to use different terminology, different concept, which is the regression. That means we want to see some specific variables. It's very important for us to understand the intercept, the plus the intercept, which is beta 0, and beta 1, which is the coefficient of variable x. So data, so we're going to have this data, guys, see? Odometer and price, right? How to predict? We use the regression, data analysis. One of these options, guys, the stuff of the functions of the data analysis of the Excel, it's regression, right? Regression. We have, very clear, guys, very clear. You just put all y raw data in the independent range and dependent range, and x as independent. We put it in x range, right? So we put y, the price, that one we want going to predict, right? And here the inputs independent x range. We go back, put it in here. And labeled, this is default 5%, all right? So we're going to put that one in here. Oh, sorry, got that one wrong. So input, put that one in here. And you know, if we need residual, later I'll show it to you how to do it. Or if we need normal, no need it right now at this level. So just put, so we're going to have, right? Right, guys? Data analysis regression. Put the range of y, the range of x, and just no more than that. So there is some important variables that will help us to estimate the model, to assess the model, to check the errors, to check the significance, association between x and y. We have to be careful about it. Which one is that first one? R squared. It's important to highlight it, guys, if you have your slides. And you have standard error. Also important. It will help us to address the significance weight of this linearity between x and y. We have beta 0 and beta 1, right? This is B0 and B1, right? Okay, let's go back to the slide, but this is important to understand. P-value is important in here. Marco, do you remember when you asked me? P-value in regression, it depends on p-value to decide whether we're going to reject or accept the hypothesis. I will show you how to calculate the p-value. But normally, as a general concept of p-value less than alpha,
Okay.
reject null hypothesis. Note it down. Don't back to me. P-value, this is your final exam material. P-value less than alpha, reject null hypothesis. You can calculate the critical region, up to you. But as a p-value, but I want to cover everything for you guys. I just want you to know, We don't understand p-value. By p-value later, we're going to use some calculation to find the right p-value and compare it with the t or x that what we have, right? To see whether we're going to reject or accept one hypothesis. But that's the output, right? If you go back to the slide in here, right? It's same. Right, same output. And we have some differences because of the software used, because you use Excel. But in fact, they use, I think, Stata to with your book. Anyway, it's not important for you. We have R squared. Exactly, same location, right? Of the R squared, of the Excel output. So we have R squared. We have standard error. We have beta 1, right? 0 and beta 1. So first a question in the exam, I'll ask you to predict. That means you use predicted regression. Y hat equal to beta 0 and beta 1, x. So if I ask you to find the prediction, so I will ask you to predict. So you have to say y hat equal to the value of intercept, beta 0, and the value, so see, it's negative 94, x. Okay, that's how to predict. See, I will give you this output, but estimate or predict. So you say, well, I'll show you how to do it. But here is you put the value of beta 0 or intercept and the value of beta 1, which is the coefficient of variable x in here. Depends on the sign. If it's negative, put negative. Positive, put positive. But maybe in final exam, we will predict the one with multiple regression next week. But here is the base. Here is the important to start. Right? You know how to do it using Excel? I want you guys to know how to do it in Excel. The material is attached to your book, and just try to run during your time to know how to do regression using Excel function. Right? But in the exam, I want you, this one will be provided, and I will ask you some question about it. Take it? Okay. So, the intercept, here is the just explanations. It's not that much important, but if we want, see, from the intercept in here, because, and the beta 1, how to explain or interpret your test or the regression output. This is the slope of the, but so for each, this is the slope of the line, which is the beta 1. This is the slope, this one, the slope of the line, whether it's positive or negative, right? This is the slope, right? But see the interpretation. Slope, beta 1, this one, beta 1. This is the slope, okay. For each, see the interpretation, they will use the real number. For each additional 1,000, or you can put 1,000 kilometers on the odometer, the price decreases by average of 94 cents. Right? That's how to find how to do interpretation. It's not that much complex, but need to understand. Need to be more knowledgeable or need to be more informed on how to interpret. We use the small figures to do the analysis, but when we interpret the data or to do conclusion, we have to use the real facts. Even the price has to be times by 1,000 to find to what extent we're going to use the, because if we measure it using the data that we have with the small figures, we're going to say, I think increase in 1 kilometers will lead to increase in part of the 0.094 cents, something like that. So that's is the best way to interpret. You have to say increase in 1,000, and you have to times the price of the beta 1, the slope, which is the increase in the odometer measured by 1,000 will lead to increase the price by 40 per 1,000 for $94. Right? That's the interpretation. Okay? But the most important part here, I'll ask you this one, and we'll ask you to find, later I will show you how to predict or to reject or accept the hypothesis using p-value, or how to decide whether p-value is small or big. All right? See, increase lead to decrease in the price because of the negative sign, right? See how to predict? Okay? So, and here, guys, we have some notes for you. Keep in your mind that every single regression have an error terms. Every single regression have an error terms. But the regression with low error terms, the regression fit your data or fit the data. Low error terms, good regression. High error terms, how to measure that? There are some requirements to meet the regression conditions, required conditions. So very important things to catch whether the error terms in this specific couple of models is better. Like if we have 2 or 3 options, we check the regression. Low regression, model fit the data, right? So we have 5 conditions, or 5 conditions of error terms, which are always must be satisfied, right? In order to determine the fit the model, the data, or fit with the data that we have. Are we going to predict some, use this data to predict some y, or dependent variable? So the first one, the probability distribution is normal for error terms. Has to be normal. So there is a function with the Excel, when you do data analysis, it will give you the output, and it will specify the error terms, standard error, the other outcomes. There is additional function to see the residual, because the residual will represent the error terms that cannot capture by this model. The second one is the mean of error terms is 0, or at least equal to 0, or near to be equal to 0, or close to 0, which is the perfect. If the error terms close to be 0, that means the model is perfect. All right? Or even is close to 0 will be perfect. The third one is the standard deviation of error terms, which is sigma epsilon, that one, a Greek, both Greek characters in here. Sigma epsilon, right? Sigma epsilon, which is the standard deviation of error terms. For all values of x, it has to be homoscedasticity. That means all error terms same across all independent variables. For example, I have y is a dependent, right? Dependent variable, right? I have x1 firm size, right? x2 leverage, x3 age of the firm. For example, there is an error for each independent variable. When we said standard deviation error constant of the sigma epsilon for all variable of x, that means error terms for all these variables, x variables, 1, 2, 3, it has to be homoscedastic. That means it has to be independent of each other. That means there is no association between the error of x3 and the error of x. We call it, in the indigeneity test, we call it homoscedasticity. I think that's the name, right?
I don't know how to say it.
Yeah, it's a new terminology for you. Homoscedasticity, guys, if for example, you work as a financial analyst or accountant, management accountant, with any public listed firm or private firms, they will ask you to do some association between two independent and dependent variables. Okay, or let's say regression, to find the effect of the market, economic downturn, like now, or some crisis on the firm value or the share price, for example. Okay? You have a couple of X to control. X1, like economic growth, size of your firm that you work on, number of directors, share, a lot of stuff to predict the right value of share price within this period. For example, right? So you have to run regression. Control for this, x1, x2, x3, to predict share price. All right, I agree with you. Later, you have to provide them with additional analysis to find that your model that you did, the regression is right, is fit 100% with the data that you have, or you used to predict this y, right? What we call it in the indigeneity, this is called indigeneity test. They call it homoscedasticity. Still, I spent 3 years to learn this one. Sorry. Still recording. All right? Homoscedasticity errors. So, but it's not, you just, to understand that the error terms between x variables has to be independent. There is no association between error terms for xy and x2 and x3. That is the most important part to understand within this paragraph or this point or this condition. Right? No more stochasticity. Don't worry, Marco. The errors are independent, not autocorrelated errors. That means if there is an error, there is no association between x and y, not the error of x and y, the x and y itself. For example, sometimes we put in the regression some variables in here, but these variables, there is autocorrelation between them. Like, we put the leverage, right? And we put total debts. But in fact, the leverage measured by total debt divided by total assets, right? As a risk measurement. Accountants, go back, use accounting principles, right? So that's the fact. That's autocorrelated. That means these two variables is autocorrelated, one related to each other, right? We say total number of directors, not risk measurements. Let's go back to the corporate governance. Total number of directors, you put it in here as an x2 independent total, okay? And you put here total independent directors. In fact, independent directors part of the total number of directors, right? So that's autocorrelated. It has to be independent. This one has to be independent than this, than other. So that's what we call it autocorrelated. Very easy, huh? Compare what we have done. Huh? This is just, guys, the Excel will give you the output. But I want you guys to understand, what does it mean by this one? What does it mean by autocorrelated? What does it mean by heteroscedasticity? What does it mean by standard deviation of errors? Just don't worry about the names, but understand the logic, right? The last condition here is the errors are independent of the independent variables. It has to be independent to each other. Like here, x4, everyone has to be totally independent. And this, by the way, this is additional stuff. This, not that one, this one is independent. But this one, we call it normally in the statistics or in accounting, we call it control variables. But that one independent, this one dependent. By the way, how to identify the control variables? It has to be based on your independent variables. You can't put like X is the firm, X the price of the car, second-hand car, right? But you can't put, for example, the size of the land of the park. There's no association between the size of the land or size of the house or like stock price or any other non-related variables. So these control variables, it has to be identified by this one. It has to be some association, right, between the control variables. Also, there is some association, right? How is the regression? See, it's very easy, but this is just additional explanations to keep in your mind that this stuff has to be controlled and measured. So if you want now, so we have from this three assumption we have, you can see that the mean of the standard deviation of the errors are independent and equal to each other, right? So all take same shape and same size in here. So x1, x2, x3, the error terms in here equal to each other, right? And take same shape, right? So same standard deviation, right? So that means expected value of y given value, expected value of given x, expected value of y. I think there is another one. Huh? Yeah. Expected value of y for the variable x2, expected value of y given a second independent variable, third independent variable, expected value of y given, this is probability, right? So, and that's one beta 0 to beta 2y. This one x and this one is y. So you can see the standard deviation is same for all. That means we met the important condition of the, that means it's independent and not autocorrelated, right? But I mean, with x, which is normal, x has to be different, takes different value based on x value, right? Assessing the model, which is the also important part. So the least square method in accounting or in statistics, guys, there are several models and techniques to test the association between x and y. Right? There is least square method. I think they call it ordinary square method. We have fixed effect, we have random effect, right? This function is not available in the Excel, right? It's not provided in your material. But that one, this one is available in other, but the basic things as a default method or techniques to test the association between x and y provided with the Excel is a square list method, right? So in here, how to assess? When we assess the model, that means we have to find whether or not there is a linear relationship needs association between x, y. When we say increased number of the student study hours per week, will lead to higher score in the exam. For example, there's a linear relationship, 100%. Sometimes we don't find a linear relationship. For some reason, maybe there's other effects that lead to, even if you study more than a couple of hours per week, your score will be, and there's no association between, because there's some other reason. That one will be explained by the, when we do the model 10 for next week. Huh? Oh, that's fine. Go ahead. So between X and Y. Consequently, it's important to assess the model and check whether it fits the data or not. Several methods provided to assess, testing, estimating the coefficient using descriptive measurements. Right? Let's see how we go with it. So the first method or the condition, the mean error is equal to 0 or close to be 0. So these sort of things will be explained by the Excel output when we do some specific calculation to find the mean is equal to 0 or close to be 0. So the second one, if the sigma epsilon, which is the standard deviation of error terms, is small. As much we have the small error, that means tend to be close to 0, or that means the model fits the data. Small error, small data. How to calculate that? The next couple of slides to illustrate this couple of conditions. Therefore, can use sigma or standard error. Do you remember when I said to you guys, please highlight these two important ones? Right? There is standard error as measure of the suitability of using the linear model. Right? If it's small standard error, that means the model fit the data. That means small, the standard deviation of errors, very important to assess the model that we are used to be consistent or fit the data. Unbiased estimator of is given by S squared, S epsilon squared, that one, standard deviation. Unbiased estimator. So we call it S. How to get S? Squared epsilon, this one. Continue with our example. The odometer and the price. Odometer was X and Y. Odometer X, you sure? X, Y, it's independent variable. And Y is price because it's dependent variable. All right, let's see how we go with it. How to find the standard error of estimate for example 1 that we have, and describe what it tells you whether this model is fit the data or not. What we can do in here, it's hard to assess the model manually, I think, but it's better to compare S, which is available standard error, not standard deviation, standard error, SE, have this one. So SE, if you go back to slide 5, it was equal to, Nathan? 0.45. Yeah. Standard error equal to 0.4. This one is important because it will be 2 or 3 marks for this point, maybe 5. Right? And you have Y bar, the average value of Y, price. If we go back to the data, how to get a Y bar, guys?
Oh.
The average data of price, Y, dependent variable. So how we got the Y bar? If you have the data, go back here, listen, see? This is the Y, right? You just highlight it. You can find, sorry, one down. Yeah. Ah, this is the odometer, sorry. So, the Y equal to, where's the Y in our example? $16.2, right? This one here. When you want to find the value of the average value of any column of the data, you just highlight this column. It will give you in here 16.2 stuff, right? Or you can do the stuff in here, guys, function. You know how to do the function, guys? Your business report will be on Monday. We'll do on Monday. See, guys, here, equal average. It will give you direct. Just you say average, this one give it to you directly. AV, average, right? Oh, sorry, not that one. Okay, no problem. You can use that one, right? 16 point, right?
Yeah.
So that's you, guys. You need to know some basics, functions, some knowledge about the functions. That is the, most of you guys, you're going to get passed, but you need to have something, you carry something with you when you get job. Yeah, I've done one statistical unit, data analysis and function and statistics, counting. So that means you need some experience in Excel. Excel is very good software, by the way. There's additional function you can buy it from online. Anyway, this is your, so but this is just a basic, but there's additional function, amazing. It will cover everything. So, but this is basic things we need to learn, right? We got the average, and okay, there is something. We got the average, we got the standard error. What we have to do to find, to decide whether the standard deviation of error terms is small or big, or to meet the rule of thumb, we call it. Rule of thumb. So that means what we're going to do, we divide the standard error value from the Excel output. You got it, guys? You know how to get this value from? Huh? No? Yes or no? From the Excel output, standard error. X bar, it will be allocated in the exam, final exam. So divided, it will equal to 2.8%. That is the amount of errors that we capture from this model. Based on rule of thumb, the standard error of that's the basic. That is the range of the conditions, the requirement of the rule of thumb. If the standard error more than 20%, that means the large standard error, implying the regression model does not fit the data. But now we have very small standard error. That means the model fits the data, right? That is the rule of thumb. I may ask you to find the calculation and find rule of thumb in the final exam. That's why I said it's a heaps of questions allocated under, or requirements allocated under question number 6. That's why don't ignore it. Question number 6, very important, will equal to 30%, 28 to 30% of your total grade. So be careful about it. Don't ignore it. Like what were the students before the previous semesters did, they ignored this question and they lost a lot of marks. Anyway, all right? So this here, testing the slope. The slope, as we said, is the beta, is the coefficient, which is that give us the linearity of the association. See, in this model in here, we expect that we have 3 different outputs or relationships with when we run any regression. Okay. The one positive association, increase in A, increase in X, increase in Y. Negative association, increase in X, decrease in Y. And another option, there is no association between x and y. 3 different outputs or relationships or linearity concepts to know. For the first one in here, the linear relationship different inputs x and y lead to the slope not equal to 0. That means there is an association, positive association between x and y, right? Positive association between x and y. But in other case in here, the slope equal to 0. That means there is no association, no linear association between x and y, right? Odometer don't affect the price of the car. For example, color, for example, right? So the desire of the market, there's other effect we can't control. Maybe it will give us the right association or the linearity to explain the linearity between x and y. So in here, there is an association, positive, and here there is no association between the association output equal to, or the slope equal to 0. Right? No association between x and y. Right? So, when we draw the inference, guys, about beta 1 and beta 1 hat, it's beta 1 is important because we are talking about the actual. Here's the important part is beta 1 equal to 0. That is the evidence we have. But if we want to test that there is some association between 2 variables, we have to test beta 1, which is different than 0, different than 0, less than 0, or greater than 0. We go back to hypothesis testing, right? This formula is no need to remember because it will be already, no need to remember. This is an output of the extra function, right? But the important part to understand, which is the beta 1 equal to 0, which is null hypothesis, and alternative hypothesis is beta 1 different than 0, greater than 0, or less than 0, right? To test the belief, to run the regression, to find the linearity between x and y, right? So the error variables is normally distributed. This because you have to do some. So different degree of freedom will be -2 because you have 2 variables, odometer and price. So that's the extra output, if you remember it. So test statistics, guys, in here, -13.5889. If we want to reject or to decide whether we reject or accept null hypothesis, what we have to do, we have to test the p-value. What is the general concept about p-value? P-value less than alpha, reject null hypothesis. Correct? You with me, guys? You need rest? We're going to finish this one. Just a couple of 10 slides. So p-value equal to, so p-value less than alpha equal to reject, right? Null hypothesis. That is the general concept of the accepting or rejection null hypothesis. P-value equal to, so p-value equal to 2.84, right? E minus 24, right? This one is the figure from the extra output, right? Yes. You with me, guys? That means to find whether p-value small or greater than alpha, that means you're going to say 2.84 divided by 10 power 24. Exactly. That means we got very, 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 very small value compared with the default one. Which one? In the Excel? 5%, right? Guys, when we run any regression, we have 1% significant level, 5%, and 10%. The default one, using Excel, it's 5%. With ANOVA, with all the functional, they put 5 as a default. In our question, we use 5 as a default. I think you saw. Did you see me when I didn't play with the stuff? I put it as it is. I leave it as it is. So it was 5%, significant level. 3 different significant level. 1, 5. We use 5 as a default one. As a 5 as a default, it's 5%. The alpha equal to 5%, right? 4.05, right? Okay? And here, 2.84 divided by 10 power 24, it's a big number. If we divide this one, it will be very small, part of this one. Very small compared with alpha, right? That means if you compare this one with 0.1155 and a 10, so we can reject or accept null hypothesis. It's very small value compared with alpha, p-value, very small. If it's less than alpha means very small, we reject, right? We reject. Now we're going to reject because if we compare it with 1 and 5 and 10 in the exam, if you ask you to compare it with 3 levels, you have to reject. Because p-value very small compared with alpha, if it's 1. Very, very small if you calculate this one. Right? It will be 0.000 like this. After 1 meter, maybe you can find 1 value of 141 or stuff.
You will find it too.
Right? You got it, guys? So p-value less than alpha means reject null hypothesis. Note it down, please, because that one, maybe I will ask you about it in the exam. So you just follow this strategy. This is important. See now, from our model, we learn a couple of stuff in our final exam. How to predict, how to estimate, how to calculate the standard deviation of errors, how to know X and Y, how to find the interpretation, how to conclude using the real numbers with thousands, how to know the sign of the, whether it's positive or negative of the beta. What's the mean? Beta is the slope. Now we know how to reject or accept null hypothesis using, no need to go to the end of the book and find the test. No need, just p-value of the beta 1. Right? Beta 1. All right? Compare it with the significant level we have. We're going to reject at all the levels of the that means there is a differences, there is an association, linear association between the odometer and the price. Because based on the fact they have, beta equal to 0, there is no association. But when we do test, we find there is an association between the odometer as a proxy of the age of the car and the price of the car itself. Right? Are you with me, guys? Good. So we have another things, we call it determinant of correlation, correlation of determination. This correlation of determination, guys, in fact, is, so now we estimate and check the error terms and test the slope. Right? Couple of steps, done. Now we have coefficient of determination. In fact, this is the third important concept in the regression. The coefficient of determination. We want to measure the strength. This is very important. The strength of the linearity. So to what extent The price of the car depends on the odometer of the car itself. 60%, 50%, maybe there is 20% for the color. There's 10% for the model of the car. But at this stage, we have to explain the strength. The rest, based on our model, simple linear, the rest we call it error, because we don't have additional independent control variables. We say error at this stage, right? Error. But we're gonna see the R square in here, coefficient of determination. It will give us the strength of the linear relationship between X and Y. All right? So, coefficient of determination measures the proportion of the variation in Y can be explained by X. To what extent X can explain, to what extent the odometer can, using odometer as a measure, as a proxy of the age of the car, can estimate or predict the price of this used car. We use R square, right? R square takes the value between X and Y, 0 and 1, right? R square takes the value between 0 and 1. There is no R square equal to 2. No. 5%, 10%, to 1. Okay? This is very important in the regressions and in the analysis. If you work as a management accountant in banks and stuff, reading reports, ask you to predict, because you are a master of accounting or any post-grad, if you are post-diploma, right, Marco, you're going to have a position or you're going to get a job based on your qualification. That's right. So you will say, yeah, I'm holding master in accounting. Okay. Can you do some analysis using this one, this annual report? Sorry, is used. Not that one. The annual report for the firm. You have to use the facts. R square, one of the important concepts that you have to understand. It will give you the strength of the association or linearity between X and Y. So it will be allocated between 0 and 1. 1, that's the top range of R square, means perfect association between X and Y. And 0 means there is no association between X and Y. Based on, clear? Based on our Excel output, if you remember, I said to you highlighted, right? Go back to the stuff. Slides number 5. So I said to you guys, R square equal to 65. Right? That means, right? It's perfect, I think. Right? R square. If you go back to the Excel computer output, so R square is equal to 65%. So 65 of variation in Y, selling price, is explained by the odometer. The rest of 35 remain unexplained by this model. How to detect this 35%? How to reduce it? And at this stage, guys, we said it's error because unexplained, right? How to reduce this 35? Add more. Model of the car, price, color, model, stuff. Age of the owner of this car, maybe if he's old, if you look at the car. If he's, right, guys? Got it? Coefficient of determination, R. Clear? Very important, that one. This is another requirement of question number 6. If you look to the Excel output, it's easy. Say, it's easy. But there is a lot of explanations. If I ask you what's the R square value in the Excel output? If you don't know and add explanations, you have to say R square 65% is good, but still there is 35% remains unexplained by this model. For example, so you have to give some interpretation. So using the equation now. So now we finish models, introduction, models, estimation, slope, Excel output, plot, error terms, standard error, calculate, we find the error less than 20 rule of thumb, right? And we got coefficient of determination. Now we have, we've met all the conditions, right? If you remember it. And the standard deviation using the slope errors, same with all the errors of the independent variables, x1, x2, and x3. If you remember, it takes same shape, same standard deviation. And we said, what else? Anyway, so we finish all the conditions. Autocorrelation, we made, it's not autocorrelated. Now we're going to use the model. We use the model, regression. Why? Predict from the Excel times 40. 40, if you want to predict selling price, 3 years old, that one, Ford Laser with 40,000 kilometers. Ford Laser with 40,000 kilometers. That's, so the X equal to the odometer reading 40,000, right? So we see, they use just the small figure. But when we conclude, we use the real numbers to conclude that if Ford Laser, the odometer increased by 1,000, it will lead to decrease by 7. So if we want to predict using the Excel output, and for this specific car, Ford Laser with 40,000 kilometers, the price equal to $15,800, for example. If he said negotiation, maybe you can get it with 13,000, right? Got it, guys? See? To see the steps? Imagine when you report any case study or you have data and you want to do a report. So you have to follow all these steps. You have to meet all of these conditions. That's why it's not easy to publish your work or to convince others because it will be used. Do you think these reports among the communities or staff or public administrators is easy to convince others? Either they will use it. If it's not built upon the real facts and well tested with all of this, meet all of these conditions, then it's just fake. So no one will address it. We don't have time to give you another example. So I made a lot of stuff with my. So let's see the correlation. Next slides, I think, which is the important one, coefficient of correlation. Oh my gosh. So, correlation. The coefficient of correlation, we call it correlation matrix, is used to measure the strength of relationship between two variables. Do you remember when I told you at the beginning of the today, when we start, I said to you, correlation will give you So, okay, I will show you the correlation. And I will give you an example from the real work of the publicly listed firms. Oh, sorry, I missed one I from my family name, huh? That's a published paper on 2016 in Emerging Market Review. This is top journals in finance and accounting. And here we've done some calculations. I'll show it to you guys. Right? So you've done some descriptive statistics, some stuff. This is based on industry because we want to see the proportion, right? Percentage, right? And we've done some independent, see, we explained the independent variable, and dependent variable and control variable, all. That's the model, that's the regression. But here we use the next week one. Not just one, we use, not just one, we use multi. Here we put this one as in, we combine everything in one, but because we don't want to do a lot of notes in here. So we put it, but in fact, it's one y and couple of x's. x1, x2, x3, couple of independent variables. C, we are interested with correlation, or coefficient of correlation. What they said in the slides in here, guys? If you go back, so measure the strength of the linear association between two variables. That means the correlation, if you have in the regression model, now we have maybe, let's say, 11 control variables. It will give us the association between this and this, and this and this, this and this, you know, see the correlation? If you didn't see the correlation before, that's a descriptive, guys. This is descriptive, mean, median, same what we have done, exactly. This is the definition of the factors we use. This is not your, it's not out of your, it's not, we use square, least square, or LIS we call it. See, exactly same with what you have done. That is the regression. That is the correlation. That's the correlation. See, guys? I think we can use this one. Make it clear. See the correlation? It gives us the association between each variable, this one and this one, the family and busy. For example, family ownership, or let's say size, and number 5, the age. It gives us the association between every variable that you have in the control variables. Why? This is the question. One day, we have a project to analyze some case study among the Australian public listed firms. We forgot to run the correlation, because the correlation will give you the right association between X and Y. This is the important part in here, first one. They give you the right association between X and Y. Sorry, this one, next one, here. Right? And we forgot to run the regression, correlation. One of our staff said, where's the correlation? I said, no need. We sent to the journal and they returned it. They said, where's the correlation? Because they want to see whether there is a direct association. Because this association may be affected by one of the autocorrelated, one of the other control variables, or a dependent variable. So they want to see the correlation, because they will give us the association between two variables, right? This is the importance of correlation. All right. So, okay. So if you see such a stuff, that's a correlation. Anyway, such a table, let's say the correlation. So in population we have, we call it P, correlation, pi. If it's -1, because it will be allocated between -1 and 1, right? If it's -1, that means perfect negative association between X and Y. If the correlation is positive, the sign is positive, that means it's positive association between X and Y. If the correlation equal to 0, that means there is no significant association between X and Y. Right? That is the benefit of the association, or the correlation, or the coefficient of correlation. It will give us the association between X and Y, between X1 and Y, X2 and Y, X3 and Y, X3 and X1, X2 and X1, X1 and X4. That is the correlation, right? So the coefficient can be used to test the linear relationship between two variables, as I said. For population. For the sample, we use rho. This one we call it rho. Coefficient for sample, rho. The rho is actually very complex to find because this is the logic of the rho calculation using the softwares. But this is not important because if we, by the way, in the exam, I will provide you with a small correlation, like maybe a three variable or four variable, right? It will be like that. Okay? So it will be like that. Sorry, here. So it will be like that. This is your correlation with them. And I ask you to find the, for example, the association between this variable and the, it will be specified, it will be identified, it will be clear. So no need to remember this formula. I will provide you with a correlation, if there is a correlation question, right? I'll provide you the same with the one I showed you in our paper published in the Major Review. So we'll give you the correlation. They're very small, 4 variables maybe. We don't have time to do a lot of calculations, right? But within the same question number 6, right? So if you want to test the coefficient of correlation in here, for P or for R, depends if it's population or sample. So again, P equal to 0, which is the coefficient of correlation, not equal to 0. So again, the output, we're given only to remember, but you have to know that you have to meet the characteristics of the correlation. That means between -1 and 1, right? -1 and 1. So that's why we said it goes to the minus in here, down to the example in here. If the coefficient of correlation determines by linear relationship, example 1, if you go back to the example, you're going to have P equal to 0, P or correlation, coefficient of correlation not equal to 0. That means we're going to use t-test in here. So t-test equal to 19. This one already will be given, depends on the equal. So it's very complex to find the to do the calculations because you don't have time to do it manually and you don't have computer. So it will be R squared in here. It's provided. So the sample coefficient of the correlation using formula or Excel, it will equal to minus 0 because the negative association, if you remember, negative association between X and Y. So high odometer will lead to low price. Negative association. The correlation of the coefficient will be in minus, right? So regression diagnosis in here, there is some errors occurred due to the normality distribution or the variance is constant for all variables. So 3 important conditions required for the validity. Now we're going to test the validity. This is the last couple of slides. Talk about the validity of the conditions of the regression we use. The error variables normally distributed, it has to be met. We have to meet this condition. The variance, that means the standard deviation of error terms have to be equal among all the independent variables, right? And the error terms has to be independence between each independent variable. How can we diagnose this validation of these conditions? There is some specific histogram and conditions to find. Examine the residual. If you go back in here to the question, guys, to the Excel, when we run, right, analysis like regression, okay, there is here, residual, or plot, up to you, what you want. So, what happened? Couple of requirements. So there is here, data analysis, regression. So you just have to identify an output standard. Yeah. Oh my gosh, what happened? I think because we use same page. Regression. Residual output. Labels. So what happened? What they said in here? Regression. Output range will. Ah, okay. So it has to be.
That's the output range.
Yeah, let me just identify. Ah, because we have this one here.
What you're saying is
Okay. No.
go over that table.
So let's delete this one in total. The output, right? Delete. It goes down. Okay, sorry. So data analysis. All right. Output range will be in here. Residual plot stuff up to you. It depends. So they will give us a lot of stuff and it includes the. Where's the diagram? It has to be diagram, right? Anyway, so we'll give us the residual. So how to do? You have to do another calculation to find the normality of the error term. That's the error terms, residual output. Right? So you have to do that, but it's not. Don't go a bit because as soon as we got the standard error significant, we can decide whether we meet the rule of thumb or not. Right? But this is an options and stuff. I think, let me just find something. Okay, now the data analysis. Ah, yeah. Oh, this one, no. I don't want it. It comes after we delete this stuff. Okay, data analysis. I know you're a bit busy and tired, but just a moment. Distribution. Here. Where's the output? Anyway, this comes, see? This one? Has to come in here. Right? This one, anyway, I'm looking for this one. So, right? Oh, goes. Anyway, we can't follow it till evening. Then save. Anyway, huh? So that's the process. So residual, as I said to you guys, have to meet these conditions and no charging. Yeah. So which one is that? Not now. Later. So we are then, I think. Yeah. So the residual analysis, we've got data regression. Choose standard, as I said, as I showed to you guys. There's down standard error or residuals. So the non-normality in here, we've got. So you have to find. This is the important one, guys. How to check the normality of the. You have to follow the. So check. Bin, create bin, part of your assignment, huh? Create bin and see it's semi normal distributed data, right? The shape more likely to be normally distributed, right? So that's normally distributed. We can assume that's normally distributed, right? So that's how to test the residual standard deviation, right? So no need to remember these formulas because it will be provided by Excel. Okay, as can be seen, the standard residual histogram appear to be bell-shaped. right? So in here, there's two cases to check heteroscedasticity, means the standard deviation of error terms between the control value or among the control value which has to be independent, right? So according to the first shape, it's the errors go up and down among x value in here, right? So, and the one more flatter, that means the second model will be more perfect, because this one, it will be go up and down, in different times, but that one more flatter, so which is be more acceptable. So that means we met the condition of heteroscedasticity. This is not consistent, and this is the first one, and this one has to be more flatter like this. That one is not acceptable. So non-independent error variables, that means there is autocorrelation. So that means there is association between x1 and x2 and x3 and affect the value of y. That means there is some causality effect between x and y. The value of x or the value of y not explained well by the value using the value of x, for example, because there is autocorrelated between x1 and x2, which affect the value of xy. This is what is meant by autocorrelation, right? We have, that's what I said to you guys, x1, x2, x3. So it has to be independent, this one and this one. This one has to be independent. If there is some association between this one or this one, or this one or this one, or this one or this one, it will affect the value of y. It has to be independent. So otherwise, there is autocorrelation. Can be detected also using graphic. Now, because we use some advanced software like Stata or SAS or R, we can detect the errors of the autocorrelation problems using just small codes. At the end of the regression, it will control the autocorrelation. That's why it's too hard to find some association between x and y and the real life. Link it to the theory, right? So this one, as I said to you, so for the this model patterns and the appearance of the residual over the indicated autocorrelation existed. So for the first one, so you can see the patterns using running up and down, right? The patterns running up and going down and running up again, right? So replaced by run negative residual. So at the beginning go positive and then go to the negative and then get to positive. But for the model 2, in here, the residual patterns are, for the first one, the residual patterns are autocorrelated, right? Because it's not independent between the independent variables is not independent in here, right? It's dependent on each other, xy and x1, x2, x1, x2, x3, x4. But of the second model, it's, they said, oscillating behavior of the residual around, so 0 and up to down. So the main, the stuff like the base is 0, up to 0 and down to the 0 with the same, around almost same range. So the value, same observation that always, maybe you can say it's rest of the data will be fit. But the second model is more.
So it's not autocorrelated?
The second one not autocorrelated, but the first one autocorrelated.
Okay.
You know, in the real life, you can't find the best, because you talk about the data with couple of thousand of observations. So you can find it not auto-correlated 100%. There are 100% there is some effect. Right? So nothing optimal in life. So nothing optimal. So there is, maybe with the second model, there's a little bit autocorrelation, but not different than compared with the first one. This is highly correlated, but the second one, it's perfect, better than. So not optimal. So optimal it has to be zero autocorrelated between the independent variables, right? But nothing perfect in the life, as I said. But what they do, and the technicians, they find some codes when you put the regression x, y equal to x1, x2, x3 error terms. They put some codes to reduce the autocorrelation between the independent variables. Otherwise, you have to report that. So otherwise, there is an association. So this autocorrelation will affect the association between x and y. If there is no if you control the residual in the regression, maybe, and your autocorrelation, there is no autocorrelation, maybe there is no association. But if you drop the residual code from the model, right, and there will be some autocorrelation, maybe you will find some association, which is prohibited in the research, right? So outliers, do you remember the outliers, guys? Model number 1. You just done your this semester test. I'll give you an example about outlier. See, guys, we have data, we have y and x, okay? We have a slope, okay? What does it mean by outlier? Optimally, in statistics, the panel data that you have, you want to test, it has to be distributed among to the slope, right? Within the slope, the data. But sometimes you got one that doesn't mean by outliers. That means the firm size, it has to be within the same range of the firms. But if you compare the total assets of small shop in carousel with total assets of, for example, PHP bulletin will be maybe there. If they like, it will be here maybe. It's outlier, very big compared with the shops in the carousel, right? Very small businesses, but that one very big. PHP bulletin. You talk about the biggest mining company around the world. A couple of years ago, but because of some stuff, come maybe number second. Anyway, here, this is outliers. Maybe one very small, right? So what we have to do, we have to do some codes to make this one close to the slope. We call it mensurization. So it's not prohibited, but it will give you, the data will fit the model. The association will be more suitable and very accurate, right? Because you control for the outlier. So the outlier at 1%, it has to be reduced as 99%. It has to be within the range of the data, right? If you need any paper published now, you will find the report that once they collect the data from the annual reports or download from databases or from stock market, right, as accountants, you need any published paper in the accounting journal, they will say, we control for the mensurization, right, at 99%. That means they reduce this outlier and make it within the range of the distribution of the data. Okay? That's what does mean by outlier. See, that's an outlier. But this is negative, mine was positive, same. right? See the outline? Out of the range of the data. They have to make it within the range. Otherwise, it will affect the direction of the linearity between x and y. Because it's outlier, and it will change the association from negative to positive. Or if it's positive, maybe it will be 0, no association between x and y. That's what does mean by the outlier. So just to understand the outlier and how to address this outlier. Right? So we have to address that one. You can address it manually using Excel, or you can use the codes if you work on Stata or software and other advanced software. So it's very easy using just code. Monitorize this variable and make everything. That's why we monitorize the variables one by one. Or the meters, monitorize it. If there's an outlier, it will be reduced. Second, price, age of the car, blah, blah, blah. So we make it consistent among all the database. Right? So to avoid the diagnosis among this one. So this is the last step, I think. So that's developing the model. That's the how to detect if there is any diagnosis among the models or data. So develop the model, and the model has to be supported by theoretical. When you talk about the agency, right? That means if the CEO more conservative, right? That means he will get less cost of debt because he disclosed and transparent everything, any problem, any fact, any stuff to the market. So nothing hidden. There is no agency or information hidden or asymmetry between the capital provider and the CEO. If the CEO overestimated, yes, we got. It's difficult for this CEO to get less cost of debt or cheap cost of less of cost of debt with less interest rate because he's overestimated. He make himself like a biggest CEO around the world, but in fact he did a lot of prohibited activities or a lot of earnings management because these capital providers is not easy. They have their special system to detect any frauds or earnings management or playing with annual reports, right? So it has to be theoretically. For example, you have agency, you have information asymmetry, you have stuff. You know what I mean by theoretical? This is very important. If you do any research later or to understand the concept, when we do a lot of research, we have to develop our research based on a theory, theoretical base. It has to be acceptable. You can't say it's difficult to convince the market that your firm is very small and you want to borrow a couple of billions. It's too difficult. Theoretically, there is information asymmetry or agency. But if as we go to market, they will get low cost of the low interest rate loan, right? Loan with low interest rate. So this is theoretical base. You have to link it to the theory. It has to be within the fact of the field. You can't say the size of the land, for example, reduce or increase the firm value of the land in South Perth. It has to be theoretically accepted and built upon some theoretical fact. Gather data to variables in one model, draw the scatter to see whether the data is normally distributed and there is some association between x and y. Check the requirement conditions of errors, as I said to you guys. If the model fits the data, go ahead, do the regression, right? That is the steps to detect the diagnosis. If there is no diagnosis, everything fits with the data, that means you are now ready to run and find if there is and report your data, right? Finally, we'll see you next week. Or tomorrow, right?
Tomorrow morning.
Any question, guys? Yeah, I think you have a question, right? Question, guys? Question? Okay, I'll ask you. All the best, guys, will be on your report. See, I will be in tomorrow. Come and see me. Don't hesitate. Come. Ask many questions. Okay? I have been allocated this 2 hours for you guys. Please come and see me if you have. Read your report. If you have any questions. 1:30 to 2:30. I'll make it 2:04 for you. From 1:30 to 4, not just 2:30. 2.5 hours. Venue? 407? For 10D. I forget because of the diagnosis of the regression. For 10D. That's my room number. Okay? 1:30 to 4 will be in for you guys. So please come, huh? I want you guys to get more than 20. Don't accept less than 20. Never, never. There will be some error. Huh? Some error terms in your regression. Okay? Yeah.
When you compare two populations, is it necessary?
We're going to compare it to more. Okay, go ahead. Go ahead.
When you're comparing two adaptive populations, is it necessary to consult the histogram if your sample size is large?
No.
Or is it if you sample?
No, it's a good question.
Yeah.
If it's ANOVA,
Yeah.
you have the histogram. If it's not ANOVA, the rest of the question. So you have to check if among to the histogram, if it's not normal distributed, you have to see which, remember at model 4? Central limit theorem. You have to say that.
Even with ANOVA?
No, we're not already report the histogram.
Okay.
But you assume that it's normal if the sample size is greater than 30 observation. So I wanted to report that in question 2 and 3 and 4.
Okay.
Okay, say that's why I said to you, you have to model 4 may be important.
Yeah. So
Because of this note, by the way.
So it's not necessary to consult to look at the histogram or to.
Never. For 3 and 4 no.
Okay. Yeah.
In fact, go ahead. That's what you want. I want. Go ahead. All right, guys. No question. Good luck.
Thank you.
Come and see me, huh?
Yeah. Thanks for that.
Look to see you
See you
tomorrow.
tomorrow morning,
No
mate.
worries. Tomorrow morning? Yeah.
Corporate? Yeah, corporate.
Oh my gosh. I think I'll bring my
What other units you have?
the corporate accounting intermediate for Lisa.
Intermediate. Yeah.
Yeah,
For Lisa, yeah. How's she?
she's not too bad. Yeah, good.
Yeah.
Yeah.
You know, when I had these units with her, she was alone. She was doing her classes and her tutorial classes.
Because I will be the UC for this unit next semester.
Yeah.
So she complained a lot. I'm
I
alone.
had to-
I need
I
someone.
went for every consultation time to meet her.
And she's not in.
Actually, so she was fine.
Yeah, she's good, but she didn't come regularly. Okay, I have some deal for you. Come.
Alright, sweet.
I will finish my class with these guys for corporate accounting.
You have class now?
No, not now.
Right.
Tomorrow I will finish at 11.
Okay.
11:10, come to my room. You will find me.
But
This
it's just 2 minutes if you don't mind. I just want to know what
Okay,
test
come.
Yes, sweet. So the first
Come
one.
on, come look today.
Thank you.
I think I need some wheelchair to go on my
Man, this
car.
guy's in meeting. Even you were, right?
No.
Are you doing the feast as well?
Yeah,
Yeah.
yeah, he's student as well.
Yeah.
You also?
Yeah.
Alright. You guys have to.
Yeah.
Alright. So the first one, is it like F test, the ANOVA?
No.
Okay.